Hello everyone and welcome to my YouTube channel NN Fabian Chemistry. Hope you're all doing great. So today we shall be learning how to write ionic equations in chemistry. To begin with, what is a chemical equation? A chemical equation is a simplified way of representing a chemical reaction. Now, chemical reactions can be represented as word equations. For example, carbon reacts with oxygen to form carbon dioxide. Write a word equation for this reaction. It is pretty simple. Let's see how we do it. So we have carbon plus oxygen to form carbon dioxide. So that is a word equation for a chemical reaction between carbon and oxygen. But what are the inconveniences of representing chemical reactions as word equations? First of all, you should notice that word equations take up too much space. Word equations as well do not tell us the number of molecules that react together. And equally, the names of different elements are not the same in different languages. I take, for example, the element nitrogen. In French, it is called azote. So you see, representing chemical reactions as word equation, this is just one of the limitations, because for the same element, nitrogen, you can see two different names. In English, it is actually nitrogen, and in French, it is azote. Chemical equations can also be, chemical reactions can also be represented as symbol equations. In symbol equations, we use the chemical symbols of the elements and the chemical formulae of the compounds. For example, the chemical reaction between carbon and oxygen to form carbon dioxide can be represented in symbols as such. We have carbon plus oxygen. We know oxygen is a diatomic element to form carbon dioxide. So here we can see that in symbol equations, they take up less space, and equally, we can see the exact number of molecules of each reactant and products. Now that we've seen what a word equation is, a symbol equation is, what is therefore an ionic equation? So an ionic equation is a special form of symbol equation that shows only the ions that react together. For us to be able to write ionic equations for chemical reactions, there are a set of rules we must follow. Let's take a look at the rules. Rules for writing ionic equations. So let us look at these rules. They're actually going to guide us as we write the chemical reactions using symbol equations for some cases. So if you look at it, the first case says write down the balanced symbol equation with state symbols. We know the state symbols could be solid, liquid, gas, and aqueous. The second thing is to write down the ions present in the equation. Now we should take note here. Any reactant or product that is solid, liquid, or gas is not split into ions. Next, we have to cross out the ions that are the same on the same side of the equation. These ions are called spectator ions. They do not take part in the chemical reactions. Next, we have to write down only the reactants and products that are left to get the ionic equation. So, how can we tell if a compound forms ions? Here are a few rules to guide us. So compounds containing a metal and a non-metal would form ions. That is, ionic compounds would form ions. Let's look at an example. Sodium chloride is an ionic compound because it is made up of a sodium atom, that is a metal, and a chlorine atom, that is a non-metal. So this compound will form ions, and it will form the ion Na plus and Cl minus. So this is an example of an ionic compound. It is made up of a metal and a non-metal. Equally, we can take a second case, calcium oxide. Calcium oxide. Calcium is a metal and oxygen is a non-metal. So calcium will form the ion, and oxygen also forms the oxide ions. Now, I'm sure you should be asking yourself, how do you know when to put the charge of +1, +2? For this, it is pretty simple. We know that metals would form positive ions, in other words, cations, and non-metals will form negative ions. Non-metals will form anions. So how do we know the charge to put on the ion? It is pretty simple. Just go to the periodic table, identify the group of the elements. The metals have positive ions, like we said a while ago. So sodium, for example, if we look at the periodic table, sodium is in group 1 and it is a metal. So when sodium forms an ion, it has a charge of +1. What about calcium? Calcium is in group 2 of the periodic table. Let's take a look. Here we have calcium. This is calcium on the periodic table. So calcium is in group 2 of the periodic table and it is a metal. So calcium will form an ion with charge +2. So how can we know the charge for non-metals? It is pretty simple, just like in the case of metals. Now, we already know how to determine the valency of atoms. We know that for elements in group 1 to 4, their valency is the same as their group number. Elements in group 5, 6, 7, and 8, the valency is equal to 8 minus the group number. So let's look at the case of oxygen, for example. This is oxygen. Oxygen is in group 6 of the periodic table. So the valency of oxygen would be equal to 8 minus 6. The valency is equal to 2. But oxygen is a non-metal. So the charge on an oxygen ion would be -2. Let's do one more example. Here we have chlorine. Chlorine is in group 7 of the periodic table. So chlorine has a valency of 8 minus 7, that is 1. Chlorine is a non-metal, so the charge on a chloride ion would be -1. Okay, so that is how we can determine the charge to put on an ion. So let's look at the next rule. Acids such as hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3, these will also form ions. I take the case of hydrochloric acid. We have HCl, so it will form the ions H plus and Cl minus. If we look at the case of sulfuric acid, H2SO4, it is going to form ions. We have 2 hydrogen atoms here, so it's going to form 2 hydrogen ions. And here we have a polyatomic compound, SO4. This you need to memorize it, SO4 2 minus. Similarly, for nitric acid, we would have H plus NO3 minus. And lastly, ammonium compounds. These contain ammonium ions. If I take, for example, a compound of ammonium, let's take ammonium chloride. So it's going to form ions NH4 plus the chloride ions. So these are some rules to guide us to know when a compound is going to form ions. Once more, let's take a look at the rules for writing ionic equations. Write down the balanced symbol equations with state symbols. Write down all the ions present in the equation. And we should take note once again, any reactant or product that is solid, liquid, or gas is not split into ions. We should cross out the ions that are the same on both sides of the equation. We should write down only the reactants and products that are left to get the ionic equation. Now, bearing that in mind, I want us to take a look at this example. Okay, let's take a look at this example. An aqueous solution of chlorine reacts with an aqueous solution of sodium bromide to form an aqueous solution of sodium chloride and an aqueous solution of bromine. Write an ionic equation for this reaction. Remember, we have to use our rules to help us. So if we look at it, the first rule says we should write down the balanced symbol equation for the reaction with state symbols. So here we are, we have to take the first rule. So we have an aqueous solution of chlorine. Here we go. So we have chlorine. Chlorine is a diatomic element. It is in the aqueous state, that is our state symbol, plus it reacts with aqueous sodium bromide. So we have sodium bromide. It is still aqueous to form bromine, that is aqueous bromine. Bromine is also a diatomic element. We know that the elements in group 7 exist as diatomic elements, plus sodium chloride, aqueous. Now that is the equation, but is our equation balanced? I don't think so. Let's look at it. Over here we have 2 chlorine atoms, and to the right we have just 1. So we're going to put a 2 over here to balance the equation. If we look at it, on the right we have 2 bromine atoms, but on the left we have just 1. So we put a 2 over here. Our equation is now balanced. So let's look at the second rule. Second rule says we should write down all the ions present in the equations. So let's now see how we do that. This is our compound. Now take note, covalent compounds do not form ions. Covalent compounds do not form ions. So chlorine would not form ions here. It is maintained. We have Cl2 aqueous plus sodium bromide. Sodium is a metal, bromine is a non-metal, so it is going to form ions. So in this case, this is what we would have. We have 2 sodium atoms here, so we shall form 2 sodium ions. Aqueous. We have 2 bromine atoms, so we are also going to form 2 bromide ions. Aqueous. The bromine to the left, to the left. The bromine to the right of our equation is a non-metal, so we maintain it. Plus, here we have 2 sodium atoms, so we shall have 2 sodium ions. Aqueous plus 2 chloride ions. Aqueous. Now we have to cross out the ions that are identical. So let's see what we have. Here we can see that we have to the left 2 sodium atoms and to the right 2 sodium atoms. So we're going to cross out the sodium atoms. What else can we cross? There is nothing. So what is left? To the left, what do we have? We have Cl2 aqueous plus 2 Br minus the 2 bromide ions aqueous to form Br2. Oh, sorry, it's supposed to be a 2 here. Br2 aqueous plus 2 Cl minus aqueous. So this is the ionic equation for this reaction. So this is the ionic equation. Pretty simple, right? So let's look at the second example. Write the ionic equation for this reaction. Barium chloride aqueous plus sodium sulfate aqueous to form sodium chloride aqueous plus barium sulfate solid. So get the periodic table, look up barium. Barium is in group 2. So what should be the charge on the barium ion? Definitely plus 2. So here we go. 2 plus aqueous plus, here we have 2 chlorine atoms, so we form 2 chloride ions, 2 Cl minus aqueous plus 2 sodium atoms, so we have 2 sodium ions aqueous plus, here we have a sulfate SO4. Now what charge should we put here? Take note, we have 2 sodium ions, so we have 2 times plus 1 giving us a total charge of plus 2. So what should be the charge on the sulfate ion to cancel out the plus 2 charge on the sulfate on the sodium ions? Definitely it should be negative 2. 2 minus aqueous to form, here we split up the sodium chloride, so we would have 2 sodium ions aqueous plus 2 chloride ions aqueous. Barium sulfate is solid, so it does not form ions. We would have BaSO4 solid. Take note, though it is an ionic compound, but it is in the solid state here, so it doesn't form ions. Now, what next do we have to do? We need to cancel out the ions that are identical on either sides of the equation. So here we cancel the chloride ions. Here we have sodium. We cancel out the sodium ions as well. What are we left with? We are left with barium ions on the left, aqueous plus the sulfate ions aqueous to form, what are we left with on the right? We have barium sulfate solid. So this is the ionic equation for this reaction. Pretty simple, right? If you've not yet subscribed to my YouTube channel, please go ahead and subscribe and hit the notification button, so each time I upload a new video, you'll be the first person to know. And why not share? Now, we've done 2 examples already, so let's try some few exercises now. So here we are. Please go ahead and try these exercises. We have ABC, write ionic equations for the following reactions. So go ahead, pause the video and try these exercises. When you're done, come back to the video. I believe you've tried the exercises already, so now let's see what you've done. So we begin with the first case, silver nitrate plus potassium bromide to give us potassium nitrate plus silver bromide. Take note of the state symbols. So let's begin by splitting the compounds. We have silver, Ag. Now, what charge shall we put for silver? Let's come over here to silver bromide. Bromine is in group 7 of the periodic table. It's a non-metal. So what will be the charge on the bromide ion? Definitely it will have to be -1. So what should be the charge on the silver ion? Silver is a metal, so that the charges balance up. If bromine is -1, silver should be +1. So here we would have Ag plus aqueous plus, now we have the nitrate NO3. What charge should we put? If silver is +1, what should be the charge on the nitrate so that they balance up? It should be -1. So we have that plus potassium is in group 1 of the periodic table, so and it is a metal, it should be +1 aqueous. Bromine Br minus aqueous to form, here we have K plus NO3 minus aqueous plus, take note, silver bromide here is solid, so we leave it as it is. It doesn't form ions. We have AgBr solid. Now let's cancel the ions that are identical on either sides. What do we have? The nitrate ions are identical. What else do we have? The potassium ions are identical. So what are we left with? We are left on the left with the silver ions plus the bromide ions. And what does it form on the right? We have silver bromide solid. So that is the ionic equation. Let's look at the second example. Here we have copper 2 chloride aqueous plus sodium hydroxide aqueous to form copper 2 hydroxide solid plus sodium chloride aqueous. So let's start by splitting up the ions. Again, we have Cu. Now, what charge shall we put for copper? Take note, here we have 2 chlorine atoms, so we're going to have 2 chloride ions, and the total charge would be 2 times -1, that's -2. So what charge should be on the metal copper, so that it balances up, so that it cancels out the -2 charge on the chlorine or the chloride ions? So we should have +2. Good. Aqueous. Let's move to the next, sodium hydroxide. Sodium is in group 1. We have 2 sodium atoms, so we form 2 sodium ions. Plus hydroxide, we would definitely have 2 hydroxide ions as well. To form, now copper 2 hydroxide here is solid, so we leave it as it is. Solid. Plus, here we shall split up 2 Na plus aqueous plus 2 Cl minus aqueous. What next do? We cancel the ions that are identical. We have 2 chloride ions, they cancel out. We have 2 sodium ions, they cancel out. So what do we have? We now have Cu2 plus aqueous plus 2OH minus aqueous to form Cu OH2 solid. So that's the ionic equation for the second example. Let's move to the next. We have aqueous bromine. Oh, we should have it here, sorry. Aqueous bromine that reacts with 2 potassium iodide to give us iodine aqueous plus 2 potassium bromide aqueous. So let's go. The bromine molecule here is non-metal, so we maintain it as it is. We would have Br2 aqueous plus potassium iodide. It is aqueous, so we're going to split it up. Iodine is in group 7, so here we shall have 2K plus aqueous plus 2I minus aqueous to form. We have I2 aqueous plus 2K plus aqueous plus 2Br minus aqueous. I hope you know why we don't split up the iodine molecule here. It is non-metal, so we do not split it up. So let's now see what we can do to cancel out. Over here we have 2 potassium, 2K plus, cancelling out with the 2K plus. What else can cancel? Nothing. So we are left with the aqueous bromine on the left plus 2 iodide ions, aqueous, and on the right we have an iodine molecule, aqueous, plus 2 bromide ions, aqueous. So that is the ionic equation for this reaction. Now let's look at a shorter way of writing ionic equation. But take note, this method I'm about showing you works only when we have a precipitate which is formed. Now, what is a precipitate? A precipitate is a solid substance which is formed when 2 or more solutions are mixed. Let's look at the case we have on the board here. We can see silver nitrate aqueous, that is a solution of silver nitrate. We have potassium bromide aqueous, that is we are talking about a solution of potassium bromide. Potassium nitrate aqueous, that is a solution, and we have silver bromide solid. So this is a precipitate which is formed when these solutions are mixed, silver nitrate and potassium bromide. A precipitate is formed. So this is the solid substance and it is the precipitate. So here we have the precipitate. So for reactions in which a precipitate is formed, we can simply write the ionic equation by observation. How do we do it? We write the precipitate as the product. So in this case, we're going to write the silver bromide as the precipitate, and for the reactants we write the ions that make up this precipitate. We have silver bromine, so we shall have silver ions, aqueous, plus bromide ions, aqueous. So that is the ionic equation. Pretty simple, right? Once again, take note, this method works when we have a precipitate, that is a solid substance that is formed during the reaction. Okay, try to balance this by observation. Take note, you have to identify the precipitate first. So go ahead, pause the video and try to balance this just by observation. Okay, let's see what you've done. Now, if you look at this equation, you discover that the iron 3 hydroxide is solid. So this is the precipitate in this reaction. Here we have the precipitate, which is formed when these solutions are mixed together, iron 3 chloride and sodium hydroxide. So to write this ionic equation by observation, this is what we do. We write the precipitate, FeOH3 solid. Now, what are the ions that make up the iron 3 hydroxide? So here we would definitely have the hydroxide ions, and here on the product side we have 3 hydroxides. So we're certainly going to have ion, aqueous, plus we have 3 hydroxides. So here we're going to form 3 hydroxide ions. Now, what is the total charge on the hydroxide ions? We have 3 times -1, that is -3. So what should be the charge on the ion formed here, so that it balances up with the -3 charge on the hydroxide ion? Definitely it should be +3. So here we have +3. So this is the ionic equation for this reaction just by observation. Once again, take note, this works when we have a precipitate which is formed. That is when one of the products in the reaction is solid. Okay. If we look at this example, we cannot balance it by observation because when we look at the products, there is no precipitate formed. So in this case, we will need to follow the steps I described a while ago to balance or to write this ionic equation. I want to believe you enjoyed the video. Please go ahead, like the video, subscribe to my YouTube channel, and remember to share the video. And when you subscribe, do not forget to turn on the notification button so each time I upload a new video, you'll be the first to know. Thanks so much for watching and have a great time. Bye-bye.